Hi, what is the value of k, given that you have k to the power of 4 equals 3 to the power of 4? Let's have it to the solution. From here, we can have it as k to the power of 4 minus 3 to the power of 4. And let's set everything to be equal 0. Let's rewrite this 4 as k to the power of 2 in parentheses to the power of 2. 2 times 2 will give us 4 minus 3 to the power of 2 in parentheses to the power of 2. We set everything to be equal 0. So this is the difference of 2 squared. Remember that when you have a to the power of 2 minus b to the power of 2 always equals as when you have a plus b in parentheses multiplied by a minus b in parentheses as this. So when you apply it to this, we are going to have k to the power of 2 plus 3 to the power of 2 as this, again multiplied by k to the power of 2 minus 3 to the power of 2. We close it. We set everything to be equal 0. For this particular expression to be equal 0, is either we have k to the power of 2 plus 3 to the power of 2 equals 0, or we have k to the power of 2 minus 3 to the power of 2 equals 0. So from here, let's say case 1. We have k to the power of 2 plus 3 to the power of 2 equals 0. You can have this as k to the power of 2 plus 9 equals 0. And from here we have k squared to be equals minus 9. To get the value of k, when we take the square root of both sides as k squared, will be equals positive or negative root of minus 9. This and this we cancel. We have k to be equals positive or negative root of 9 times minus 1 will give us minus 9. Then recall that when you have root of a times b equals root of a times root of b. So when you apply it here, we are going to have k to be equals positive or negative root of 9 times root of minus 1. So from here, recall that root of minus 1 equals I in a complex space. So from here, we have k to be equals positive or negative root of 9 times I. And so we have k to be equals positive or negative root of 3 to the power of 2 times I. This and this we cancel. So we have k to be equals positive or negative 3i. This is complex solution. Then let's say case 2, where we have k to the power of 2 minus 3 to the power of 2 equals 0. Recall, this is the difference of 2 squared. This one has power 2, this one has power 2. A squared minus b squared always equals a plus b in parentheses multiplied by a minus b in parentheses. So we are going to have here to be k minus 3 in parentheses multiplied by k plus 3 in parentheses, everything equals 0. For this expression again to be equal 0, see that we have k minus 3 equals 0, or we have k plus 3 equals 0. From here we have k to be equals 3 as the first degree solution, and k equals minus 3 as the second real solution. Then recall that we also have k to be equals positive or negative 3i as our complex solution. Then let us check. Then let us check for the complex solution where we have k to be equals positive or negative 3i. So for the first one, we have when k equals 3i, then here will be 3i to the power of 4. Then is it going to give us 3 to the power of 4? From here, when you have ab to the power of n equals a to the power of n multiplied by b to the power of n. From here, we are going to have this to be 3 to the power of 4 multiplied by I to the power of 4. Then is it going to give us 3 to the power of 4? Then recall from the complex number that when you have I to the power of 2 equals minus 1. So this implies that when you now have I to the power of 2 in parentheses to the power of 2. Definitely here will also be minus 1 in parentheses to the power of 2. Here will be I to the power of 2 times 2. Then this will be equals minus 1 times minus 1. Here will be I to the power of 4 equals 2 times 2 will be 4. I to the power of 4 equals minus times minus will be plus. 1 times 1 will be 1. So definitely I to the power of 4 equals 1. So having known this one as this, then let us now recall from here. So we are going to have 3 to the power of 4 that multiplied by I to the power of 4. Then is it going to give us 3 to the power of 4? I to the power of 4 equals 1. So here will be 3 to the power of 4 multiplied by 1 equals 3 to the power of 4. We have here to be 3 to the power of 4 equals 3 to the power of 4 for the complex solution. And likewise, let us also check for the other one. When we have k to be equals minus this. When we have k to be equals minus 3i, so from here will be minus 3i, all in parentheses to the power of 4. Then is it going to give us 3 to the power of 4? So from here, when you apply this, you are going to have minus 3 as this to the power of 4 multiplied by I in parentheses to the power of 4. Then is it going to give us 3 to the power of 4? Then recall that we can have this as minus 1 times 3 all in parentheses to the power of 4. I to the power multiplied by I to the power of 4. Then is it going to give us 3 to the power of 4? Then recall that when you have minus 1 in parentheses, this will be minus 1 in parentheses to the power of 4 multiplied by 3 to the power of 4 multiplied by I to the power of 4 this times 1. Then is it going to give us 3 to the power of 4? Remember, anytime when you have minus 1 to the power of even number, this will always give you 1. Anytime when you have minus 1 to the power of odd, this will give you minus 1. So from here, 4 is even, so definitely here will be 1. So we are going to have 1 times 3 to the power of 4 times 1, which equals 3 to the power of 4. So from here we have 1 times this will give us 3 to the power of 4 equals 3 to the power of 4. So if you are new here and find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more maths tutorial videos. Obviously, that k equals minus 3, 3 and positive or negative 3i will satisfy this problem given to us. This will satisfy, sure. This will also satisfy. Why this complex solution will also satisfy. We have 4 solutions here because we have k to the power of 4. Bye-bye.